Hi students, problem number 12. A certain prism produces a minimum deviation of 38 degree. It produces a deviation of 44 degree when the angle of incidence is either 42 degree and 62 degree. What is the refractive index of the material of the prism? Okay, we have derived this equation in the regular class. So when a monochromatic light is allowed to pass through a prism, so there will be refraction taking place at the two faces of the prism, and finally the light is emerging out of the prism. We have studied and we have plotted the graph between the angle of incidence and the angle of deviation. So this curve is called ID curve or ID graph. Now you can very well see in this graph, you see this straight line drawn parallel to the x-axis is cutting the graph at 2 points. So at this point the angle of incidence is I1, say 42 degree. Okay, so here let us take this is 42 degree, and at this point also the deviation is the same. The deviation y-axis remains the same. So at the 62 degree also we have the same angle of deviation. Like this, I draw different straight lines. Can you see this? The third line. This line touches the graph at only one point. So at this point, I1 must be equal to I2. We have studied this, and the deviation is the least value. The angle of deviation is the least value, and that capital D is only called as angle of minimum deviation. So what is given in the problem first? A prism produces a minimum deviation of 38 degree. So deviation is denoted with the symbol delta. Okay, and deviation is minimum. When minimum deviation occurs, it is denoted with the symbol capital D. Understand? Okay. Now in this case, 42 degree and 62 degree are taken to be the values of angle of incidence and angle of emergence. So I1 is equal to 42 degree and I2 is equal to 62 degree. Okay. Now what is capital D? The angle of minimum deviation is given as what? 38. Okay, 38 degree. So here this will be 38 degree. And for these two angles of incidence, the deviation is taken as 44 degree. So I will take here, this is okay, here I will take 44 degree. Okay, this is 44 degree. So I1 is 42 degree, I2 is 62 degree, and minimum deviation is 38 degree, and in general any deviation is taken as 44. So here delta is taken as 44 degree. Now there is a relation connecting the angle of the prism and the deviation. A plus D is equal to I1 plus I2. From this equation we can find out the value of the angle of the prism. So A must be equal to I1 plus I2 minus deviation. So A is now equal to 42 plus 62. Okay, 42 plus 62 minus deviation here is given as 44. Okay, so this is 44 degree. So this is now equal to 104. 104 minus 44. 104 minus 44. Therefore, the angle of prism is equal to 60 degree. Yes, sir. Are you all understanding, students? So from this graph we find that for two different angles of incidence the deviation remains the same and that value is 44 degree. At one particular angle of that is incidence is equal to angle of emergence, the deviation is found to be minimum. So I have found the angle of the prism 60 degree from this expression, and also angle of minimum deviation is given. So how to find the refractive index? The refractive index of the material of the prism is given by the expression. Okay, so mu is the refractive index of the material of the prism, and that is equal to the ratio sine of a plus d divided by 2 whole divided by sine of a by 2. Now we have already determined the value of capital A. The angle of the prism is found to be 60 degree and the angle of minimum deviation is given as what? 38. Okay, 38 degree. Substituting these two, therefore now mu is equal to sine of. Okay, so 60 plus, so this is 60 plus capital D is 38. Okay, so this is equal to 38 divided by 2 whole divided by sine of 60 by 2. So this is now equal to sine of 98 by 2. 98 by 2. Sine 98 by 2 whole divided by sine 30. Sine 30. Okay, so this is a sine 30. So mu is now equal to sine of 49 degree divided by sine 30 is 1 by 2. So this is equal to 1 by 2 means this is coming up. So 2 into sine of 49 degree. So sine of 49 degree, we can use the calculator. Yes, sine of 49 degree is equal to 0.755. So this is equal to 2 into 0.755. So 0.755. So this will be equal to 1.51. Therefore, the refractive index is found to be 1.51. So, what is the refractive index of the material of the prism is derived from the expression mu equal to sine a plus d by 2 divided by sine a by 2, and the answer is found to be 1.51. So, which of the options? You see here option A is the right answer. Okay. Therefore, option A is the correct answer. I hope you must have understood well. Fine.